Hello everyone. The headline of this lesson is intermediate value theorem. The statement of the theorem is if the function f of x is continuous between 2 points a and b, then it takes all value between f of a and f of b. In other words, if k is a real number between f of a and f of b, then there exists at least one number c between a and b such that f of c equal to k. Graphically, that is mean if this is a and this is b, and the function is continuous between a and b, then this is f of a, and let us take it here. This is f of b. If there is a number k between f of a and f of b, then there exists c between a and b such that f of c equal to f of k, such that f of c equal to k. Example: depending on intermediate value theorem, which of the following functions has a root between -1 and 3 when f of x equals 0? We have to solve this example. We have two conditions. The first condition, the function should be continuous. The second condition, the value of the function when x equals -a should be less than 0, and the value of the function when x equals 3 should be greater than 0, or the reverse. Now, for the first function, 2 over x, it is not continuous between -1 and 3 because 0 is between -1 and 3, and 0 is a discontinuous point for this function, so this choice is wrong. For the second function, the function is continuous between -1 and 3 because the domain of this function is all real number except -3, and -3 not within this interval. Let me check the second condition. F of -1 equal to 2 times -1 minus 1 over 3 minus 1 equal to -2, -1 minus 1, -3 over 2 less than 0. F of 3 equal to 2 times 3 minus 1 over 3 plus 3 equal to 2 times 3, 6 minus 1, 5. 5 over 6 greater than 0. The second condition satisfied. Therefore, this function has a root between -1 and 3 when f of x equals 0. Let us check the third one. This function is polynomial of the second degree, is quadratic function, then it is continuous everywhere. Let us check f of -1. 3 times -1 minus 3 times -1 square minus 8 equal to -3 minus 3 minus 6 minus 8 minus 14 less than 0. F of 3 equal to 3 times 3 minus 3 times 3 square minus 8 equal to 3 times 3, 9, minus 27 minus 8. It is also less than 0 because the answer is 9 minus 27 minus 18 minus 8 minus 26. So this function not satisfy the second condition. Let us check the last function. It is also a quadratic function. It's continuous everywhere. F of -1 equal to -1 square minus 1 plus 2 equal to -1 square 1 minus 1 0 plus 2 2 greater than 0. F of 3 equal to 3 square plus 3 plus 2. It is also greater than 0. 9 plus 5 14. Also, this function is wrong. The right choice is B. Example, using intermediate value theorem, find two values such that the function f of x equal 1 minus x over x plus 1 has a root between them. Let us check the first two numbers, -3 and 0. This function is discontinuous at -1. -1 is a discontinuous point for this function, and -1 is belong to the -1 and 3. Therefore, this choice is wrong. -1 and 0, already this function is not continuous at -1, and -1 is within this interval, so this choice is also wrong. 0 to -1 is not within this interval, then the function is continuous in this interval. Let us check f of 0 equal to 1 minus 0 over 0 plus 1 equal to 1, greater than 0. F of 2 equal to 1 minus 2 over 2 plus 1 equal to 1 minus 2, -1 over 3 less than 0. Therefore, these 2 points satisfy the condition of the theorem. Therefore, it is the right choice. Let us check the last 2 points, -1 and 0, -2 and 0. -1 belong to this interval, and the function is not continuous in this interval, so this choice is also wrong. The right choice is C. Example, depending on intermediate value theorem, which of the following function has a root between 0 and 2? This function is continuous because it is a polynomial. Let us check f of 0. 0 plus 0 minus 2 less than 0. F of 2 equal to -2 square plus 2 times 2 minus 2, -4 plus 4 minus 2 less than 0. Therefore, the second condition not met. This is wrong choice. Let us check the second one. Also, it is polynomial of second degree. It is continuous everywhere. F of 0 equal to 0 plus 0 minus 1, -1 less than 0. F of 2 equal to 4 plus 2 square 4, 5 times 2, 10, minus 1. It is 14 minus 1, 13, greater than 0. This function is satisfied the condition of intermediate value theorem. It is the right choice. Let us check the third function. This function is not continuous when x equal 1/2, because 2x minus 1 equals 0. 2x equal 1, x equal 1/2, then 1/2 make this function discontinuous, and 1/2 belong to this interval. Then this function is not continuous in this one, in this interval. The first condition is not satisfied. The last function is a polynomial of degree 3. Of degree 3, it is continuous everywhere. Let us check f of 0 equal to 0 minus 0 plus 1 greater than 0. F of 2 equal to 4 times 2 power 3, 4 times 2 power 3 minus 2 times 2 power 2 plus 1. 4 times 8, 32, minus 8 plus 1, it is greater than 0 also. Therefore, it is also wrong. The right choice is B. Example, which one is true? Which of the following is true? F of x equal 3 over 2x minus 1 has a root between 0 and 1. Since the discontinuity point of this function is set 2x minus 1 equals 0 and solve this equation for x, 2x equal 1, then x equal 1 half, and 1 half belong to this interval, is between 0 and 1. Therefore, this function is not continuous in this interval, and this choice is wrong. F of x equal 2 over x minus 3. The discontinuity point of this function is x equal 3, and 3 belong to this interval, so also this choice is wrong. F of x equal 2x minus sine x. This function is continuous everywhere because its domain is all real number. Therefore, it is continuous. The first condition satisfied. Let us check the second condition. Find f of negative pi equal to 2 times negative pi minus sine negative pi equal to negative 2 pi plus, since sine is odd function, then sine negative pi equal to negative sine pi, negative sine negative plus sine pi equal to sine pi is 0. The answer is negative 2 pi less than 0. F of pi equal to 2 pi minus sine pi equal to sine pi is 0 equal to 2 pi greater than 0. The second condition satisfied. This function has a root between negative pi and pi depending on intermediate value theorem. The last function, f of x equal to x power 2 minus x plus 2, it is a polynomial of degree 2. It is continuous everywhere. The first condition satisfied. Let us check the second condition. F of 0 equal to 0 minus 0 plus 2, 2 greater than 0. F of 2 equal to 2 times 2 power 2 minus 2 plus 2, 2 times 4, 8 greater than 0. The second condition not satisfied. The right choice is C. True or false? If limit f of x when x approach to c equal L and f of c equal L, then f of x is continuous at x equal c. True, because the condition of the continuity satisfied. F of c exists, limit exists, the value of the function at x equals c equal to the limit. All the three conditions satisfied, the function is continuous. Number 2, if f of x equal g of x, for x not equal to c, all points except c, and f of c not equal to g of x to g of c, then at least one of the two functions is this continuous. Also, this statement is true. The function equal at all points except one. If we take this f of x and if we choose this g of x and c is 0, for example, f of x equal to g of x at all points except 0. G of 0 is 2, f of 0 is 1. Then f of x is continuous, but g of x is not continuous because f of 0 not equal to the limit f of x when g of x when x approach to 0. A rational function may have an infinite number of points of discontinuity. False, because the denominator of the rational function is a polynomial of degree n, and the polynomial of degree n has at most n x-intercept point. Therefore, the rational function have infinite number of point of discontinuity. I will complete this lesson by solving the ministerial question on the subject of intermediate value theorem. Question number 2. Using intermediate value theorem, find two values such that f of x equal to negative 3x squared plus 5x plus 2 has a root between them. Let us check. This function is continuous everywhere. Let us check f of 1/2 equal to negative 3 times 1/2 square plus 5 times 1/2 plus 2 equal to 3 over 4 plus 5 over 2 plus 2. Negative 3 over 4 plus 5 over 2 plus 2. This the answer of this value is greater than 0 since we have positive 2 here. F of 0 equal to 0 plus 0 plus 2 also greater than 0. Therefore, this choice is wrong. 3 and 1, f of 1 equal to negative 3 plus 5 plus 2 greater than 0. 7 minus 3. F of 3 equal to negative 3 times 3 squared plus 5 times 3 plus 2 equal to 9 times negative 3, negative 27 plus 15 plus 2 less than 0. This choice is true. Let us complete f of negative 1 for the third choice equal to negative 1 and negative 3 times negative 1 squared plus 5 times negative 1 plus 2. It is negative 3 minus 5, negative 8 plus 2 less than 0. F of negative 2 equal to negative 3 times negative 2 square minus plus 5 times negative 2 plus 2. Negative 3 times 4, negative 12 minus 10, negative 22 plus 2 also less than 0. This choice is wrong. For the last choice, f of 1 equal to greater than 0. Find it already here. F of 0 also we find also greater than 0. Therefore, this choice is also wrong. The right choice is B. Depending on intermediate value theorem, which has a root between 1 and 3. All these four functions are continuous because they are polynomials. Let us check the first one, f of 1 minus 3 times 1 square equal to negative 2 less than 0. F of 3 equal to 1 minus 3 times 3 square, also 1 minus 27 less than 0. This choice is wrong. For the second function, f of 1 equal to 1 minus 3 plus 7, 1 minus 3 minus 2 plus 7 greater than 0. F of 3 equal to 3 square, 9, minus 9 plus 7 also greater than 0. This choice is also wrong. For the third function, f of 1 equal to 1 minus 2 equal to negative 1 less than 0. F of 3 equal to 3 power 5 minus 2 is greater than 0. This choice is true. Let us check the last function. F of 1 equal to 1 minus 2 minus 4 less than 0. F of 3 equal to 3 times 3, 27, minus 2 times 9, 18, minus 4 times 3, 12, 30 minus 30 plus 27 less than 0 also is wrong. The right choice is C. Number 4, depending on intermediate value theorem, which has a root between negative 1 and 2 when f of x equals 0. This function is discontinuous at 0 and 0 belong to the interval negative 1 to 2. Therefore, this choice is wrong. This function, the discontinuity point of this function is 1, and 1 belong to this interval because it is between negative 1 and 2. So also this one is wrong. Let us check this function. It is continuous everywhere. Let us check the second condition. F of negative 1 equal to 3 times negative 1 square, negative 2 square, 4 times 3, 12. F of 2 equal to 3 greater than 0 equal to 3 times 2 minus 1 square. Also, it's greater than 0 since I have square here. So the right choice is none. Number 6, depending on intermediate value theorem, which has a root between negative 2 and 3 when f of x equals 0. This function is discontinuous at 0 and 0 belong to this interval. This function is continuous everywhere because its domain is R and there is no discontinuity point. There is no points make the denominator 0, since when I want to solve this equation for x, then x power 2 equal negative 1 and x equal negative positive square root negative 1, not a real number. Therefore, it is continuous. Let us check the second condition. F of negative 2 equal to negative 2 negative 1 over negative 2 square plus 1, negative 3 over 4 plus 1, 5 less than 0. F of 3 equal to 3 minus 1 over 3 power 2 plus 1. It is greater than 0. Therefore, this choice is true. Let us complete. X minus 2, it is discontinuous at 2, and 2 belong to this interval. This function is continuous everywhere. Let us check f of negative 2 equal to 2 times negative 2 square minus 5 times negative 2 plus 8. 2 times 4, 8. negative times negative plus 10 plus 8 greater than 0. F of 3 equal to 2 times 9, 3 square 9 minus 5 times 3 plus 8 equal to 18 minus 15 plus 8 greater than 0. This choice is wrong. The right choice is B. Question number 7. Using intermediate value theorem, find two values such that f of x equal x plus 2 over 2x minus 1 has a root between them. Okay. This function is not continuous at 1/2. So x equal 1/2 is discontinuous point for this function, and 1/2 belong to this. It is between 0 and 2. Therefore, this choice is wrong. Also, 1/2 is between -1 and 1. Also, this choice is wrong. -3 and 0, this function is continuous between these two values. Let us check the second condition. F of -3 equal to -3 plus 2 over 2 times -3 minus 1 equal to -1 over -6 minus 1 -7 equal to 1 over 7 greater than 0. And f of 0 equal to 0 plus 2 over 2 times 0 minus 1 equal to 2 over -1 less than 0. Therefore, this choice is true. Question number 9. Using intermediate value theorem to find the two functions such that f of x equal to x power 3 minus 3 over 2x power 3 plus 16 has a root between them. When okay, this function, let us check the point of discontinuity of this function. 2x power 3 plus 16 equals 0, factorized by 2, x power 3 plus 8 equals 0, factorize summation of 2 cube, x plus 2, x power 2 minus 2x plus 4. Therefore, we have 2, x equal to -2 is discontinuous point for this function. 1 and 0, it is continuous between 1 and 0. Therefore, let us check the second condition. F of 1 equal to 1 minus 3 over 2 plus 16 equal to -2 over 18 less than 0. F of 0 equal to 0 minus 3 over 16 -3 over 16 less than 0. It is wrong choice. -1, -3, -2. It is between -1 and -3. So it is wrong choice. F of 1 is less than 0. We found it here. Let us find f of 2. F of 2 equal 8 minus 3 over 16, 2 times 3, 8 times 2, 16 plus 16 equal to 5 over 32, greater than 0. Here I have less f of 1 less than 0. Therefore, this choice is 2. -2 and -1, since -2 belong to this interval, so this choice is wrong. The right choice is C. Number 10, using intermediate value theorem, find two values such that f of x equal x power 3 minus 3x plus 1 over x minus 2 has a root between them. the point of discontinuity of this function is x equal 2, since 2 make the denominator 0 and 2 not belong to the domain of this function. F of negative 1, since this function is continuous in this interval, let us check the second condition. F of negative 1, negative 1, power 3, negative 1, negative 3 times negative 1, 3 plus 1, over negative 1, negative 2. 3 over negative 3 less than 0. F of 0 equal to 0 minus 0 plus 1, 1 over 0 minus 2 less than 0 also. So this choice is wrong. Also, this choice is wrong since 2 belong to this interval. 0 and 1, we found f of 0 here, it is less than 0. Let us find f of 1. 1 minus 3 plus 1 over 1 minus 2 equal to negative 3 over negative 2 less than 0, and f of 0 also less than 0. Therefore, this choice also is wrong. F of 2, 2 and 3, it is wrong. Negative 3 over negative 2, it is 3 over 2 greater than 0. Therefore, f of 1 is greater than 0, f of 0 is less than 0. This choice is true. For the last one, since 2 belong to this interval, therefore this choice is wrong. The right choice is C. Number 11. Using intermediate value theorem, find 2 points such that f of x equal x power 3 plus 2x minus 1 has a root between them. This function is continuous everywhere because it is polynomial of degree 3. So I need to find the value of f of 1. It is 1 plus 2 minus 1 equal to greater than 0. F of 0 equal to 0 plus 0 minus 1 is less than 0. So this choice is true. F of, let us check, f of negative 1 equal to negative 1 minus 2 minus 1 less than 0. F of negative 1 less than 0. F of 0 is also less than 0. So this choice is wrong. 1 and 2, we found f of 1 here. Let us find f of 2. Let us find f of 2. 8 plus 4 minus 1, 12 minus 1, 11 greater than 0. F of 1 greater than 0 and f of 2 greater than 0. It is wrong choice. F of negative 1, we found it here. It is less than 0. Let us find f of negative 2. Negative 2 power 3, negative 8 minus 4 minus 1 less than 0. F of negative 2 is less than 0. F of negative 1 also less than 0. This choice is also wrong. The right choice is A. The last question in this set, depending on intermediate value theorem, which of the following function has a root between negative 1 and 2? Let us solve this question here. This function is continuous because it is polynomial, or all the three functions are continuous because they are polynomials. So let us check the second condition of intermediate value theorem conditions. F of negative 1 for the first function equal to 3 times negative 1 square, it's 1, minus 6 times negative 1 plus 5 equal to 3 plus 6 plus 5 greater than 0. F of 2 equal to 3 times 2 square minus 6 times 2 plus 5 equal to 3 times 4, 12, minus 6 times 2, 12, plus 5 greater than 0. This function is wrong choice. For the second function, f of negative 1 equal to negative 1 minus 4 minus 3 less than 0. F of 2 equal to 8 plus 8 minus 3, 16 minus 3 greater than 0. This choice is true. Let us check the last function. F of negative 1 equal to negative 1 power 3 plus 7 times negative 1 minus 2. Negative 1 power 3, negative 1 times negative 1 minus 7 minus 2 less than 0. F of 2 equal to negative 2 power 3 plus 7 times 2 minus 2. Negative 8 plus 14 minus 2. Negative 10 plus 14, it's greater than 0. Less than 0, greater than 0. Also, this one is true. The right choice is D, both B and C. See you next lesson.